Hi, hello, good morning, everybody. For this talk, Divya can't be with us today, but no worries. You are going to be able to see that talk if you're interested about Jetpack DataStore. So it's going to be like a movie theater talk for this one. If you have any question for her Twitter is there, so you can send a message to her, obviously. And that's it. Enjoy.
Hi everyone, my name is Divya Jain. I am a mobile app developer based out of San Francisco. I have been developing mobile apps, especially Android, for over 7 years now. I am very fond of and active in the Android community. So you can find me on Twitter through the handle or on GitHub email. So feel free to reach out for any technical help, questions. Before I continue, a big shout out to all the organizers of Android Makers for giving me this wonderful opportunity. And I'm super grateful for all of you being here. Today, I'm going to talk about Jetpack DataStore, which is a modern data storage solution library. Now, we as developers have always come across use cases where we want to persist some data in the app, whether it's because of handling offline scenarios or reduce network traffic or make the app start up in a quicker way. There are various ways of persisting data in the app, and today we'll take a quick look at some of them, especially shared preferences and how shared preferences can be migrated to Jetpack DataStore. So first, let's start with an overview of what shared preferences are. Now, Shared Preferences API is used to store simple key value pairs in the app. For example, to store some primitive data like if the user has logged in or the user's username or some settings, it provides simple methods to read and write from a shared preferences file, which is managed by the Android framework. It's a single instance class, usually shared by all the clients. Also, in order to update the data or make any modifications, you need to use a special editor object. Now let's take a small example of saving users' first and last name in the Shared Preference API. Now one can either get an existing file or create a new one by calling get shared preferences. And then when we want to write values to the shared preference, we use the editor by calling the edit method. And then either call apply or commit to save the changes and persist the data. Now, when we want to read these values, we again have methods like getString or int, which takes in the key of the value we saved and returns the corresponding value with an optional default one in case there is no key present. Now, shared preferences is easy and great, except it comes with its own challenges. The read-write operations happen on the main thread, which means for any transaction, the UI thread is blocked. There is no type safety, which might lead to poor error handling and uncaught exceptions, and it becomes super hard for debugging. Also, the behavior might lead to inconsistent, mismatched data across your app, and hence today's topic, which is Jetpack DataStore. So Jetpack DataStore is a modern era data storage solution which was introduced as part of Android Jetpack. It allows you to still store key value pairs or typed custom objects, but in a safe and a more consistent way. The biggest plus point is it uses coroutines and flows, which allows for asynchronous data storage without blocking the main thread. It also uses protocol buffers to store this data. Now, one might ask, what is a protocol buffer? It's simply a serialization of data mechanism that's much faster than an XML or a JSON serialization and is platform independent, language neutral, and pretty easy to understand. Now, every data that is updated or read is transactional, which ensures consistent and precise data operations. Jetpack DataStore comes with two kinds of implementations. There's a Preferences DataStore and a Proto DataStore. We'll go briefly into each of these implementations. Now first, let's look at a Preference DataStore. Preference DataStore is very similar to SharedPreferences in the sense that it also uses key value pairs to store data, does not provide any type safety since there is no predefined schema required. So let's look at an example. First, we add the DataStore Preferences dependency, and we then use the Preference DataStore delegate to create an instance of the DataStore, which then can be used anywhere in the app. The delegate is the one that ensures that there is only one single instance of it throughout the app. Next, we define the keys for the data and the values that we want to store. So let's go back to our saving users first and the last name example. Here, we define the keys using the preferences key for string, integer, etc. Now let's see how do we save the data in the data store now. Here we see a function save user to preferences store using an edit function, but this edit function is actually now a suspend function and needs to be called from a coroutine context. And if you see here inside the lambda, we have access to mutable preferences, which lets us either update or add the values we want to modify against the keys. Similarly, to read from the preference data store, there is a data store data property that exposes each of the values corresponding to the key it was defined with through a Kotlin flow. So from the example, the preference data store looks very similar to the shared preferences, but it still comes with its own benefits. Some of which are A, it's safe to call the read write on the UI thread, since under the hood, it's actually deferring to the input output thread to make the call. There is no commit or apply needed to save the change. Instead, every update to the data is transactional, which ensures consistency. Also, current state of the data is available throughout the app through the power of Kotlin flows. And there is solid error handling support, unlike shared preferences, which is actually prone to throwing random parsing exceptions at runtime. Now let's talk about Proto DataStore. Instead of key value pairs, if we wish to store custom typed objects, that's where Proto DataStore comes into picture. It provides the ability to persist custom data typed objects with protocol buffers with a predefined schema. Because of the schema, it provides out-of-the-box type safety. So let's see how this works. Again, we first add the necessary dependency. Now here, we said we need to define the schema first. So again, going back to the example of the user's first and the last name, here we need to create something called a proto file that looks something like this. Basically, this file is what consists of our predefined schema, which here has two strings for the first name and the last name and the app's package name. This proto file needs to be stored under the path that's shown here, which is the app source main proto folder. Next, we need to define a class for serialization that actually implements the serializer defined by the type in the Proto DataStore. Also, this is the class that actually describes how to read or write the data type using the protocol buffers. And again, to reiterate, protocol buffers are one of the faster data serialization mechanism. Now, once you have the schema defined and the serializer described as shown, we can now create the data store as shown here. And this instance of the data store now again can be used anywhere in the app. So let's again try and save the user's first and the last name to the Proto DataStore now, following the schema that we defined. So Proto DataStore provides an update data function, which gives you the current state of the data as an instance of the defined data type and updates the data transactionally in an atomic read, write, modify operation. For reading the user object from the Proto DataStore, one can again use the data property to expose this data through a Kotlin flow. Now, one question that arises here is, if we are storing objects, why not use a data persistence library like Room? The thing to note is that if you're storing small, simple data sets, which doesn't need a partial update or referential integrity, then Proto DataStore is an ideal solution, since we avoid the overhead of writing and maintaining a full-fledged SQLite-based database. But if it's a large and a complex enough data set with needs for partial updates or relationship between tables, then Room is an ideal solution. Now, let's say we already have an existing app with shared preferences implemented. There is also an easy migration tool to use the new preferences data store. Android provides a class called SharedPreferences Migration. So when one is creating the preference data store, if you just pass the name of the old shared preferences, the migration will be automatically performed. So here, if you see in this example, we pass the old shared preferences name to the shared preferences migration along with the context. And after the migration is done, we can access the data through Kotlin flows and reading of the preference data store as we saw before. So to reiterate what we've talked about till now, let's look at the comparison between shared preferences, preference data store, and Proto DataStore. Now, first is async API support. Now, shared preferences does offer some asynchronous support, but there is a need to manually switch between threads and the UI thread is basically blocked for most of the operations, potentially leading to application not responding errors and UI janks. But DataStore comes with a fully asynchronous API and uses the power of Kotlin coroutines and flows. Hence, there is no blocking of UI thread. The other side of it is that SharedPreferences does support out-of-the-box synchronous operations, but those are actually very costly to the main thread. And hence, DataStore doesn't come with an out-of-the-box, ready-to-use synchronous support. One can still use the run blocking mechanisms to provide some synchronous support if needed, but it's really not recommended. And it's better to offload to coroutines as much as we can. Now, when it comes to error handling, it is really hard to trust shared preferences as it randomly throws errors and exceptions like class cast exception at runtime, leading to inconsistent crashes. DataStore, on the other hand, comes with a fully supported error handling mechanism through the Kotlin flows error handling system. With Proto DataStore, because of the predefined schema, there is also an added benefit of full type safety ensured. Now, when it comes to data consistency, because shared preferences lack atomicity, it means there is not a guarantee of the recent data being reflected immediately across the app. But with DataStore, the API is fully transactional, follows strong ACID assurities, and there are only transactional atomic operations possible. Last but not the least, there is no migration support to shared preferences, but with DataStore, there are easy migration mechanisms available out of the box, including writing only few lines of code to migrate from shared preferences to the DataStore itself. With that, I conclude my short talk about the Jetpack DataStore and would again say Jetpack DataStore is a strong modern data storage solution that lets you persist small, simple data in either key value pairs or typed objects and utilizes the power of Kotlin coroutines and flows to ensure that data is stored asynchronously, consistently, and transactionally. If you're still using shared preferences, migrate to Jetpack DataStore and reap its powerful benefits. Again, my name is Divya Jain. If you have any questions or are looking for sample code or would like to discuss anything DataStore or in general Android related, feel free to reach out on Twitter, GitHub, or my email. Thank you very much.